All right, good morning, everybody. We're looking at the work dated 2/17 today. Before we get started, I think I'm just going to be having one video today. All the videos are on the class website. You could watch those. You could pause them while they're going because I know I have to talk a little bit fast to get through this. And also, I want to encourage you, if you're having trouble with doing some of this work, please try to find someone in the room who does understand it and get some help. If you look at the class website, here's the home page, and you can see that the address is up there. It's mrcross.cmswiki.wikispaces.net. You can just go to the Hopewell website and look under the faculty names, and then click on the globe next to my name. That'll take you right there. If you see the links over here on the left, this first one will give you, you can print up copies of any of the work that we're doing, along with the solutions. And then below that, you'll notice we've got PowerPoints and videos. At the very top are the videos that we're doing right now that I'm showing you in class. Again, I encourage you to watch them over again if you need to. Try your best to understand this stuff. All right, so we're talking about today is rational expressions. Now, basically, that's just we're taking polynomials and stacking them up in a fraction. To simplify, all you've got to do is factor the numerator and then factor the denominator and then cancel out any polynomials that they both have in common. So let's take a look. If you take a look at practice A number 1, you've got 3x plus 12 over x plus 4. And basically, if you take a look, all we've got to do is the bottom, the denominator can't be factored, but the top can. The greatest common factor is going to be 3. So when we take the 3 and divide 3x plus 12 by 3, we get x plus 4. Now when we rewrite that, you'll notice we've got x plus 4 over x plus 4. That's anything divided by itself is equal to 1, so those guys cancel out, leaving us with the number 3. And then that's our answer. If you take a look at number 3, looking at the top, the numerator, we've got x squared minus 9. There's no greatest common factor. However, you'll probably notice that it's a difference of two squares. So, and then looking at the denominator, you'll notice that it can't be factored. So what we're going to do is that write the two parentheses and put a plus in one and a minus in the other. And then take the square root of x squared, which is x, and put it in the front of each one. And then take the square root of 9, that's just 3, and put that in the back of each one. And once we've done that, you'll notice that we've got x plus 3 over x plus 3. And anything divided by itself is equal to 1, so we can cancel that out. And that leaves us with x minus 3 as our answer. Number 6, the last one I want to do on the front part of the page, it's got two trinomials. Now, there is no greatest common factor in these cases, but they both do factor. So what we're going to do is that take the top one and rewrite it, and the a times a is going to be a squared, and if you have two numbers that multiply to get 15, but then they also have to add to get 8, 3 times 5 equals 15, and 3 plus 5 equals 8. We're going to do the same thing for the denominator. We've got a times a is going to be a squared. I'm looking for two numbers that multiply to get 10, but when you add them, you get 7. Well, 5 times 2 is equal to 10, and 5 plus 2 is equal to 7. And then in this case, I've got a plus 5 over a plus 5. Those two will both cancel out, and that'll leave us with this a plus 3 over a plus 2. And then that's going to be the answer. That's all there is. All right. Now, if you take a look at the back and practice B, what we're doing here is we're taking radicals and we're multiplying them. After we get done multiplying them, then we're going to need to simplify them in some cases. Keep in mind when you're multiplying radicals, if the numbers are on the outside, they stay on the outside. And if the numbers are on the inside, under the radical sign, they stay under there. But all that basically we're doing is we're just multiplying. So in this case, there are no numbers on the outside, and so we multiply 2 times 7, and we get 14. And so it's going to be the square root of 14. Now the next thing you need to ask yourself is that will the 14 reduce? Are there any perfect squares factors in 14? And no, they're not. 9, 4. They don't divide evenly by that. So that is as far as we can go. If you take a look at number 2, we've got square root of 6 times square root of 3. And again, everything just stays underneath the radical, so we've got square root of 18. Now we've got to ask ourselves if that reduces, and so we need to find if there are any perfect squares that are factors of 18. Well, we got 9 times 2, that's going to equal 18. And so when we rewrite this as square root of 9 times 2, well, now we can take the square root of 9. When we do that, it'll come out from underneath the radical sign, so it'll become 3 square root of 2. And then that's as far as we can go. That's our answer. If you take a look at number 18, on 18 we've got a little bit more going on, but we still just multiply straight across. Still no numbers on the outside. So 15 times 10, that's going to be 150. And then x squared times x squared is going to be x to the 4th. And then what we need to figure out is whether or not there are any perfect squares that make up 150. Well, if I take 25 and multiply it by 6, I'm going to get 150. And then x to the 4th is a perfect square. So when I separate these, I'm going to have 25 times 6 times x to the 4th. Now, all I've got to do is take the square root of the perfect squares. The square root of 25 is going to be 5, and the square root of x to the 4th is going to be x squared. Those both will come out front. The only thing I can't do anything with as far as that goes is the square root of 6, and it'll stay underneath the radical sign. And now this is reduced. Last one, you notice we do have numbers on the outside in this case, but again, it's no big deal. When the numbers are on the outside, all you do is multiply them. So when we've got negative 6 times negative 6, we get positive 36. If I've got 32 times 2, well, that's going to be 64. So what I end up with is 36 times the square root of 64. So then what I need to ask myself is, are there any factors of 64 that are perfect squares? And then what I realize is, wait a minute, 64 itself is a perfect square. So whenever you've got a perfect square, again, that's the only thing under the radical, we're going to take that perfect square. So the square root of 64 is going to be 8. And so then when I rewrite this, it's going to come out on the outside, and I'm going to multiply it times the 36. So now I end up with 36 times 8, and then there's nothing under the radical sign anymore, so I don't need that anymore, and so I just get rid of it. And all I'll have to do then is take 36 times 8 and multiply them, which is going to be 288. All right, I hope that makes a little bit of sense to you. My guess is you should be able to get through this relatively quickly. Please take advantage of the extra time and maybe finish up any of the work that you haven't got done or you're still working on. When I get back, I'm going to expect all that stuff done. All right? So if there's any questions you have, please find someone in the room that might be able to help you. And again, I just can't stress it enough. Take advantage of these videos and try your best to figure out what's going on. Again, there's all the other videos on the class website too, besides these, and you might want to watch those, and if you're still struggling, maybe that'll be helpful too. All right, we'll talk to you tomorrow. Have a good one.